Hello everyone. Today I am going to solve one more question of CSIR-NET JRF December 2023, and the question is from real analysis. As you can see, the question is from the convergence or divergence of a series. Okay, so the question is: consider the following infinite series. Summation n goes from 1 to infinity, sine of n pi by 2 over square root of n, and the second series is, as you can see here, summation n goes from 1 to infinity and log of 1 plus n square. Which of the following statement is true? There are four options basically given, but here as you can see, space is not enough, so I am trying to just tell you what are the four options. Option 1 is A is convergent or B is not convergent, B is convergent or A is not convergent, both A and B are convergent, or both and B are not convergent. Okay, there are four options. Okay, so I am trying to solve just this question and try to find the convergency and divergency of the series. Okay, so let us start. Okay, the series A, as you can see here, this is the series of the product of two series. Okay, product of two sequences. So you can write it as summation n goes from 1 to infinity, sine of n times pi by 2 over square root of n. Okay, so you can write it as summation n goes from 1 to infinity and 1 over square root of n times sine of n pi by 2. Okay, and you know the result of if this is a tip. So if a series an and bn, the product of those sequences, okay, and the series of summation an bn is convergent if the second one is bounded and first one is the decreasing sequence and decreasing to 0. Okay, so if bn is bn should be bounded and an should be decreasing sequence and converts to 0. Okay, so here this sequence is a decreasing sequence and convert to 0, and this is the bounded. Okay, as you know, the sine the sine function is bounded function, okay, between -1 to +1, and this is a convergent and converges to 0. Okay, so by Dirichlet test you can say this is the series is convergent. Okay, so by Dirichlet test it is convergent. Okay, you can't write it as a sine of n pi by over square root less than 1 upon you can write, you can't write it as a summation of sine. Some student try to write this, just why I am telling you, you can't write it as a less than 1 over or less than equal to 1 over square root of n. You can't write it as a, because you can write it as if this should be divergent, this should be divergent. Okay, otherwise you can't write it as a less than of 1 over square root of n, or less than of an if two sequences a and bn and the series of an is bn is you can write it as a less than of bn if the second one or bn should be divergent, but here it is convergent, so you can try it, you can't write it as. Okay, this time erase this. Okay, so it means what? It means this is a convergent. Okay, now move to second one or b part. Okay, so the series is the given series if log of n goes from 1 to infinity and log of 1 plus 1 over n square. Okay, it is convergent or not. How to check it? Okay, if you take this bn is suppose if you take it, this is a an, and if we take bn equal to 1 over n square. Okay, then by this limit test and tending to infinity, an over bn is equal to what? So an log of 1 over n square over bn. So you can write it as a 1 over n square means n square. Okay, now we can write it as a here limit and tending to infinity. We can write it as a this n square take here. Okay, so log of 1 plus 1 over n square raised to the power n square. Okay, and this is what? This is the e. Okay, this is the e. So it is equal to log of e. Okay, which is equal to 1, which is finite. So implies that bn again convergent. Okay, so a is convergent and b is also convergent. Okay, so the option is a is convergent and b is convergent is true, or the option a and b both are true. A and b or both are convergent is the true option, and rest of or false option. This is the question of part b, so only one option is correct. Okay, I hope it is clear all of you, and if you have any doubt please write in comment section, and if you like this please like the video and subscribe my channel. Thank you so much.